Welcome to this Skill Builder at a Glance tutorial on linear regression. Linear regression is a technique used to model the relationship between a dependent variable and one or more independent variables. It helps us understand how a change in an independent variable can predict the value of a dependent variable, and all variables must be quantitative. In simple linear regression, there's one predictor variable and one outcome variable. For example, we might ask whether study time predicts exam scores. The relationship is shown as a straight line. If the line slopes upwards, it's a positive relationship. If it slopes downwards, it's negative. It summarizes how much the dependent variable is expected to change for each unit increase in the independent variable. In real-world scenarios, though, outcomes are often influenced by multiple factors. And that's where multiple linear regression comes in, because it allows us to include several predictors. We have two or more independent variables and one dependent variable. For example, we might predict students' final grade on a stats module using both pre-test scores, so that's the score they got on a test before studying the module, as well as study time. The multiple linear regression summarizes the expected change in the dependent variable for each unit increase in the independent variables. We can estimate the effect of each independent variable while controlling for the influence of other predictors in the model. We test whether each independent variable contributes to predicting the dependent variable. Each independent variable has a coefficient estimate and a p-value. If the p-value is less than 0.05, we typically reject the null hypothesis and conclude that the predictor has a significant effect on the dependent variable. So it tells us which variables matter and which don't in explaining variation in our outcome. It's important to check that certain assumptions are met. These are: the relationships must be linear, independence of observations, homoscedasticity, normality of residuals, and for multiple regression, we must avoid multicollinearity. To summarize, linear regression predicts outcomes using one or more quantitative variables. It helps us understand which factors influence an outcome. In this tutorial, we've looked at linear regression, which involves a single outcome variable. So simple linear regression involves one predictor, while multiple linear regression includes two or more predictors. It's simple to use, but important to interpret carefully, especially when deciding whether a predictor truly matters. Linear regression is widely used across disciplines, from social sciences to economics. It helps us to not only understand the relationship between variables, but to use those relationships to predict outcomes. For further academic skills resources or to book an appointment with an SAS advisor, please go to kent.ac.uk/SAS or email us at sas@kent.ac.uk. Thank you.